name is Stephen Reiner, and I'm with the Alan Alda Center for Communicating Science, and this is Science on Tap. My guest this evening is Stephen Skeena, who is a distinguished teaching professor of computer science at Stony Brook University. Steve teaches in a shiny new building on the campus of Stony Brook University, and in that building is some of the world's most valuable commodities. And it's not gold, it's not titanium, it's not diamonds, it's information, it's data. It's the stuff that our world is increasingly made of. And Steve wants as much of it as he can because he does amazing things with it. So we're going to start out talking about big data by asking Steve, and welcome, where do we see big data operating in our lives day to day so we can better understand what it is?
Yeah, well, you know, today we're all surrounded by computer systems that are collecting increasing amounts of data. Every time you type in a search query to Google, Google records that, Google analyzes it, Google uses it to make its systems better and make them do new things. Whenever you talk into your cell phone and Siri, you give a question for Siri, Siri is recording this, Siri is learning from this. And you know, the systems all around, whenever you have sensors that are installed, video cameras that are used for security or anything like this, all these images and all this sensor data and all this text is being recorded and being analyzed, and you can learn tremendous things about the world by analyzing it. And
but that sounds rather ominous. What distinguishes big data from Big Brother?
Well, from a technical point of view, it's an amazing opportunity to teach computers how to do new things, useful things, good things. For example, when you build a system like Siri to try to interpret spoken...
This is the voice recognition software.
Of Siri.
And there's one on Android devices too. We don't want to plug Apple.
Speech recognition system.
Right.
These things learn by training on speech from millions of people, millions of recorded spoken text, to try to improve their ability to understand. The reason why speech recognition systems used to be terrible. I don't know if any of you have ever spoken to these things and they didn't understand anything. But in recent years, over the last couple of years, they've gotten much better, amazingly good. And one reason is that there's now vast examples of spoken text that have been recorded, that have been digitized, that have been analyzed. And by training on these systems, this vast corpus, you can now start to build much better systems for speech recognition, for answering web queries, for analyzing images. You know, many of you go on Facebook, you upload a picture to Facebook. You may have noticed that sometimes it now tags for all the people in the image, which of your friends were in the image with you. Okay, and in principle it does this because there are millions of images, billions of images to train on, and you know, by building algorithms that take advantage of all this training data, you can make it do amazing things.
Okay, well you mentioned that the important word algorithms. What is an algorithm? Is it possible to describe that to the uninitiated?
Okay, an algorithm is a procedure for solving a problem. An algorithm, at its simplest form, would be like a recipe. You want to make a cake, a recipe tells you how to make a cake. And it's a sequence of steps that say do this, followed by this, followed by this. Now, traditionally, a lot of computer systems were built using basically human written algorithms. Somebody sat down and wrote the recipe. And now computer systems are being built largely by, in some sense, learning the recipes as you go along. The reason why you have all this data and why it's an interesting thing is maybe you can, instead of trying to teach a computer explicitly how do you understand language, maybe you can take a look at lots of examples where you have training data to work with. And it kind of learns what are the important features of the language that's being spoken, the text that's being entered. And from that builds a model of how to speak, how to understand text. And so the interesting thing about the new generation of systems is that they are working by in some sense, learning more than by having somebody explicitly teach them, this is how you do it.
Now, before we go any farther, we need to remind ourselves, this is all happening, all made possible because we live our lives online. We enter our emotions, our desires, our tastes, our thoughts, our language, and we walk around and we're captured by cameras everywhere. An interesting statistic which is obviously subject to interpretation is 90% of the information that exists in the world has been generated in just the last two years. 90% of it is just 2 years old. That's how much we're feeding every day, huge amounts of information.
Right. Every time you enter a search query in Google, you're creating information, you're feeding it in someplace. Every time you write a tweet, or every time you appear on a camera, or every time your refrigerator sensor is connected, when you get your refrigerator connected to the internet, every time you open and close the refrigerator, that will be recorded. That will, in principle, be used to train better refrigerators, for all I know.
Right.
Okay?
So before we get too spooked out by this, because we'll get back to that later,
Right.
you don't do anything that we should worry about.
No,
you're
I'm clean.
totally benign.
I'm totally benign, and the best reason you know I'm benign, I guess, is that I am working all with publicly available data. We are not Google. We don't have access to private data. Everything that my students will work with in the lab are open data sources, things like Wikipedia. We work a lot with Wikipedia editions in different languages.
What do you learn from Wikipedia? What are you able to mine, to vacuum up from Wikipedia? And then we're going to get to this. I'm going to be like a talk show host, like Jimmy Fallon. See, this is one of your books, Who's Bigger?
Right.
But we're going to get to this in a second. This is from Wikipedia.
Well, to a certain extent, Wikipedia is an amazing thing. I don't think people realize quite how amazing Wikipedia is. There are something like 4 million articles in the English language Wikipedia. And there are more than 100 other languages which have Wikipedia editions that are substantial. There's a tremendous amount of information in Wikipedia, and it's amazingly accessible and good to work with. And you can do amazing things with it. So the way that we in our lab work in analyzing words is something we call word embeddings, which is we're going to try to think of each word as being a point in space, maybe a star. Okay, think of it as a star. And we're going to try to position the words in space so that words that mean similar things or have similar roles are near each other. Okay? So we would like to, for example, we know that red and yellow are similar words. They're both colors. Okay? And what we'd like to do is to find a representation where the points that we describe to red and yellow are near each other. How might we do that? We look at sentences or phrases that occur in, let's say, Wikipedia, and we leave out one of the words and try to guess which one it is. Let's say there is a word that says, I'm driving the blank car. What word could appear in blank? Well, it could be red, it could be yellow, it could be small. It's probably not elephant. Okay? And based on this, we try to guess what word is there. And if we are wrong, we move the star associated with that word that was there to a point where we'd be more likely to guess it next time. And by doing this, you can kind of represent the whole universe of words, figure out what their meanings are to some sense by where they sit in the heavens. Okay?
Now, there's good news in the wake of the Pope's visit, because who is number one? Who's Mr. Big throughout history, according to Steve Skeena and his laboratory?
Well, according to this, it's Jesus, okay, which I don't think is a surprise here. What we're talking about is a somewhat different project here. We had, by analyzing Wikipedia, we would want to try to take a look and figure out what is the relative significance or importance of people's reputations, of all the people that appear in Wikipedia. There's roughly 1 million people who have pages in the Wikipedia edition in English. I am one of them, okay? Any person you've heard of is one of them.
And by the way, if you go to Wikipedia, and you should do that tonight when you get home, you will learn, perhaps somewhat inaccurately, but nonetheless importantly, that Steve is responsible for the iPad.
Okay, this is a separate story that we can, well, we can talk. I was involved with a Apple. When I was a graduate student, Apple ran a contest to design the computer of the year 2000. And what did we do? We designed, we thought, what will the computer of the year 2000 be? Well, it'll be this flat tablet you can write on, and it'll be connected to everything. And this was great, except that the iPad came out in 2010.
Yeah,
So they're off by 10 years.
And how often do you get a royalty check?
Let's say my royalties have expired.
I see.
They expired before they started. But
Okay, all right. But back to who's biggest.
back to who's bigger. So if you view, if you view every person's Wikipedia page is in some sense like a biography, is a biography of them in some sense. And the question was, could you analyze all of the million people in Wikipedia and get some kind of a sense of who is a more important historical personage than other people? Okay? So what information might you have in Wikipedia to make a judgment like that? Well, certainly, if somebody's Wikipedia, Jesus' Wikipedia article is a lot longer than Stephen Skeena's Wikipedia article. You know, I'm
But
like
Jesus did not have anything to do with the iPad.
that may be true. Okay.
Okay.
You know,
At least
so
we think he didn't.
Article length is one criteria you can imagine would be about importance. You can imagine about how many times people go to search for this person's Wikipedia page. There's all that data. Every time you go on and access a Wikipedia page, a counter is being clicked someplace saying how many times did someone look at that page. And Jesus' Wikipedia page is looked at far more than mine, okay? Far more than, and that would be another criteria which you would expect would correlate with some level of importance. There's measures of centrality, okay? You would think that a important personage would have their page linked to by lots of other important people, okay? So Jesus' page is undoubtedly linked to by all the apostles, all kinds of religious figures, all kinds of important people. My Wikipedia page, not so much, right? And so measures of centrality, where do you sit in this network of pages, is another reflection of strength, okay? How often do people edit the Wikipedia page? No one is particularly interested in updating mine, okay? But I can guarantee you that primary people do. But the amazing thing is there's all this information about different people, and if you view them as grades of importance, by then crunching these numbers and analyzing them, you can get a reasonable measure of the importance or the significance or the popularity of certain memes. Okay?
Now, it's probably no surprise that Jesus is number one. It was a surprise to me that Grover Cleveland was number 98.
Okay, so when we rank this again,
Not exactly a president who you'd think of as one of the 5 great ones.
you know, again, who was Grover Cleveland? Grover Cleveland was a president who was elected twice, served 2 terms, and should have served 3 terms. If you remember, remember he had a gap between his presidency, for those of you who are presidential trivia people. But he was the dominant political figure of his age. And, you know, do I want to say Grover Cleveland is 98th and you got to believe me? The answer is no. But I do say it's a revealing thing when you take a look at where do people rank. If you take a look at analyzing the million people in Wikipedia is like the population of San Francisco. And we are in some sense stratifying who are the most important people in San Francisco from who are.
But what about looking at something like Google searches today? We know that Kim Kardashian is searched 5, 6, 7-fold more than Jesus.
Okay.
So if you did this book 50 years from now, would Kim Kardashian show up here, do you think?
So what do our methods do? First of all, undoubtedly a lot of people read Kim Kardashian's page. Undoubtedly the people who link to Kim Kardashian's page are less important people than link to Jesus' page. This much I suspect. Again, we have them, we would analyze, and it's interesting, this is the kind of thing that's interesting. Where would a Kim Kardashian rank? Where is a Justin Bieber among all the people in Wikipedia? And when we do our algorithm, Justin Bieber was like 8,000th, the 8,000th most important, most significant meme in Wikipedia, which sounds like a big deal, but that's where other teen idols would
By the
be.
way, how do you define meme, just for people who don't
meme.
know
What
that
do I
word?
mean by meme? I'm not trying to say that they are most important in that if it wasn't for Justin Bieber, we wouldn't have life on the planet or anything like that.
There are people who do believe that.
What I'm trying to say is how successful are they going to be at passing their reputation and name down through history? That's kind of the model that we try to do. We look at how they're comparing to other people. We use data from 200 years of scanned books to try to correct for the decay with which reputations have over time. 100 years from now, will there be less talk about Justin Bieber than there is now? Undoubtedly. And we can quantify this by looking at how much people are referred to in other data sources.
Okay, we should probably get on to more.
Yeah, sorry about that. Sorry.
No, don't be sorry. More sort of socially and intellectually interesting pursuits. You have an enormous amount of information that comes into your laboratory.
Right.
This is a laboratory that's not a traditional laboratory that we might imagine with cages and mice and rats and frogs.
And graduate students.
And graduate students, which are very, some of them may be here today. You have an enormous amount of tweets that come into your laboratory.
Yes. So
from all over the world.
We analyze a fraction of the Twitter feed from all the world's tweets.
1%.
Oh, I think we get 2%.
2%,
like
and elsewhere 10% comes
yes,
in.
so there again, we have a company called General Sentiment that analyzes a much larger fraction of the Twitter feed. And
let's talk about general sentiment. Sentiment, that's not intellectual, that's not facts, that's not data, that's emotions.
It's about moods, okay?
Moods. You
Moods,
try to
sentiment,
quantify.
what are people thinking positively or negatively about something? So let's take a look at Volkswagen. You know, historically, if you were to read about Volkswagen, if you were reading, let's say, first we'll go back far enough in World War II, probably in America, people probably thought differently about Volkswagen than they do now. But historically, especially during the 60s, Volkswagen was this hippie car that was, kind of cool and had, was probably positively viewed by a certain contingent and probably viewed kind of as a piece of junk by other contingent. And then it became a fancy car, a car reputable for its reliability. Its sentiment would go higher. Again, this past week, there was some terrible news about them cheating on admissions. You know, if you read the news about Volkswagen today, everyone's going to say this is bad news. This is bad news for Volkswagen. You know, and the question of can you quantify the good newsness, bad newsness of what's being said? It's a question of are they saying things that are denoting positive things or denoting negative things? Trying to understand language on a level of capturing some kind of a meaning. Okay, what is it that the universe is saying? Is one of these things you can do with social media that's very interesting.
Now, when Volkswagen at the high corporate levels decides how it is going to attempt to recover from this and regain public trust and try to recoup these billions of dollars it's going to lose because it's going to see its sales go down probably, it's going to want to look at the kind of information that you are now getting.
There's no question that there are people right now, there is a lot of damage control going on at Volkswagen. Looking at what are people saying on social media? Is there an uptick in this? When is this going to blow over? The question of what kind of an advertising campaign will you run will be a function of when it blows over. You know, when we were looking at a previous thing, Toyota had a problem with brakes, a certain number of years ago. And when you looked at our aggregate sentiment signal, Toyota was a great Japanese car.
Aggregate sentiment signal.
This would be
What's that?
What's this? Again, reading one tweet doesn't really tell you very much. But if you're looking at all of Twitter and you're looking at all the people who are mentioning Toyota, now you're looking at tens of thousands, hundreds of thousands of tweets. And now looking at what the majority of these things are saying. Now you get a fairly robust sense of what the world is thinking. And you could see, Toyota was a good car, Toyota was a good car. Oh my God, their brakes don't work. Now Toyota's a bad car, Toyota's a bad car. And after a while, the storm passes. And after about 6 months in that case, the talk about Toyota was about where it was before the incident.
So while we're on the subject of cars, we're beginning to hear about driverless cars. We know that Google is experimenting with them, even Apple may be experimenting with them. So there's a lot going on in the world of driverless automobiles. What does that have to do with artificial intelligence? It has something to do with artificial intelligence.
Okay, it's clear that...
And also big data, rather, excuse me.
Okay, so it's clear that when people think of car driving, they think of something done by an intelligent machine. So when people talk, what is artificial intelligence, my definition would be things that seem like they are being done by, when the machine's doing it, you think, my God, it's doing something smart. And driving a car certainly seems, it certainly falls into the category of something, it's hard to believe, it's difficult to believe, how can a machine do that? Well, one of the reasons why, how do these driverless cars work? They have tremendous arrays of sensors on the machine, to give you all kinds of input about what is around it, where are the nearest cars, what's on the road, what the road conditions look ahead, the GPS telling you where exactly is this car. There is a map of what's going to be ahead. All this stuff is input to it. And undoubtedly, these cars learn by basically being driven. You can imagine that what happens is, in the course of training, there is a guy sitting behind the wheel in these, driving the car around, and what the state of the sensors is and what the driver did in response to this is being recorded, and is the training data that you use to teach a car how to react to it. Okay, it sees that when it figures out that, oh, there's that patch of red there, that probably is, every time that thing goes on, the guy seems to stop. Okay, and that's one way that maybe it makes that connection. Maybe now it knows something about stopping at a stoplight. Okay.
But what happens when you want to get in your car and you want to go to a restaurant and the car says, no, that's not a good restaurant. That got some bad reviews. I want to take you to this restaurant. Now that's possible, right?
Well, again, everything is possible depending on how you program it. I suspect that's not.
But these cars can be hacked.
Well, okay. They're not going to be hacked by a restaurant chain, is my immediate sense.
It might be.
Might be.
So we're edging into this notion of big data is being absorbed, being collected, being learned, how much learning is going on, and then that gets me into asking you about this thing called deep learning.
Right.
And what deep learning and big data, what their connection is.
Yeah, I mean, there has been a very exciting breakthrough in the field of machine learning over the last couple of years. That as there were methods for learning that were in some cartoony way based on the brain, something called neural networks. That back when I was a graduate student 25, 30 years ago, people were saying, oh, these things are going to learn to think like people, and they were laughably bad, and they didn't work, and the people sort of forgot about them for a while. But suddenly, over the last last 5, 10 years, these systems now have wildly more data to train on. You can train much bigger systems than you used to be able to. And now they are getting astonishingly good at a lot of different tests. They're very, very easy to train if you have enough data. And you can build them. When you're talking to a computer, quite likely the speech recognition is working from using these neural networks. When you're when you have these systems for doing computer vision, like the face recognition in Facebook, these are being done using these kind of networks, these kind of deep learning trained networks. And it's really quite a breakthrough in the field. There's people who worked in computer vision for many, many years, and there was incremental progress year to year. And suddenly this old technology started beating the pants off the traditional ways of doing it. And so a lot of sort of things are colliding, bigger computers, more data, better algorithms, better training methods. And suddenly, there's a lot of progress in these.
And we are, if we want to call it a beast for a second, we are feeding the beast unavoidably every day. Human activity now in the modern world just supplies more information and more information and more information.
Right. Again, there's this vision that now, there was a time when the internet was so you could send mail to your friends and stuff like that. But now, a lot of, as you have more and more data coming from more and more machines, that's now becoming a real thing.
Do you try to see into the future?
I mean, I try to see in the future. You mentioned the time we invented the computer of the year 2000. So there was a time when I thought I was pretty good at predicting the future, and now I don't feel so like I got quite the same crystal ball that I had.
Why not?
Things are changing. Technology is changing amazingly quickly, and it's very it's when one sees how fast, for example, the machine learning technology has improved over the last several years. It gives more, certain things that seemed a lot harder or seemed a lot further away than one might have thought, suddenly seems nearer and less surprising.
Which brings us to something called the singularity, which is a term that was coined by Ray Kurzweil, who is now an engineer or something at Google, and it portends a time when Tell us, what is the
You know, again,
singularity?
the theory here would be that if computers keep getting smarter and smarter and people don't, at some point the computers get...
And there's ample evidence that people are not getting
Well,
smarter.
you know, you can make your own conclusions. But if the computers keep getting smarter and smarter and the people don't, eventually there comes a time when parity is reached, and then, you know, then what happens, okay? And that's what he means by the singularity. At that point, you know, computers will keep learning faster and faster, and the gap would increase. That's what the idea of the singularity is.
Well, we see wonderful things today with big data that are even more beneficial than things like a driverless car or Siri. We can see through Google searches, we can learn about disease outbreaks all around the world. We can look at what people are searching for, and there's a tremendous amount in global health and you know, all sorts of things.
There's no question that medical diagnosis will improve wildly as you get more and more medical records being analyzed by smarter and smarter systems, okay? And to try to tease out what your situation is and what interacts with what and what are important symptoms. These are the kinds of things that, you know, computers in principle meant for.
Right, but you can also have a medical condition and be curious about it and go on Google and start asking questions about it, and somehow that information will get to an insurance company, and the next time you have to get a quote about your rates, it's suddenly a little bit higher because you don't really have any protection from that information getting everywhere. So what is there to be afraid of or scared of? Let's go back to big data and Big Brother.
You know, again, everybody has different paranoia levels about technology and where it's going.
This is a particularly paranoid crowd.
Okay, you know, I don't think I'm particularly paranoid about Big Brother. You know, I'm not that interesting, and so your ratings will show this. That there are not that many people who are interested in watching me. Okay, so, you know, again, the thing that I find harder to predict is that there are more and more tasks which computers are getting better and better at. And the questions are, what things will it be that computers are ultimately not better at?
And what do we think those things are going to be? I mean, when we think about the greatest inventions, the greatest ideas, they're not, over history, they're not frequently based upon the data that went into them. They're about instinct. They're about making a mistake first and then coming up with a solution, right? I read somewhere if Henry Ford were listening to the data, he would have tried to invent a faster horse and not gone ahead and invented a car.
You know, how invention works is maybe today is a little different than it was in the Henry Ford era. Again, going back to the who's bigger thing, if you ask like where are the most famous inventors, you can start to measure who are the most famous inventors, and they all come from the Henry Ford era, the Thomas Edison, things like, you know, Alexander Graham Bell. Invention is a process has changed. You know, obviously the technology world is moving on. There's no question there's more invention today than before. But the interesting thing, you know, for society is going to be, you know, how do we, you know, use the ability to do so many things by machines, cheaper, better, turn that into a better society, and that's going to require some wisdom.
And that may be wisdom that is not accumulated by analyzing data.
Right. That's wisdom that's going to have to come from people, and you know, part of it is, I guess, you know, they can be guided by data, but obviously there's a certain level of wisdom that at least now is not something that would be captured by these kind of models.
Okay. Well, I think it's a good time to throw this open for questions. This may or may not be a paranoid group, but we'll soon find out.
I'm wondering if you have a sense, what's going to emerge as the most influential forms of big data? So are there certain arenas of social networking? Are there certain arenas of news? Certain arenas of general information that might drive policy or people's opinions?
I think if you think about big data and how it's destined to affect the world, everything around you is getting smarter. I cited the notion of the refrigerator. There is no doubt that at some point your refrigerator will be connected to the web of things, okay? And that it will know something about, I mean, what will it know, okay? Maybe it'll know how easy how even your temperature is. It'll know when your habit of when you open it up and when you close it.
It will know what you look like at 3 o'clock in the morning
when
you go down
and
get something.
It'll know what products are in there. Maybe it'll know what products are stale. It'll know, you know, and And what I think the result of these kinds of things, refrigerators will get better, okay? I think that it is going to be seemingly an incremental improvement in how many things work. And a lot of it will be look invisible and look incremental. It's not obvious, Steve was telling me a statistic about how much program is in the typical car, how much software is in the typical car. I didn't notice that change happening. Maybe I drive an old car, that's one reason. But still, that a lot of this world is a question of things incrementally getting more sophisticated. And I think that the rate at which you're going to be able to do this in response to analyzing vast amounts of data, things are going to get better, okay? And it's going to affect all kinds of different things. That's, I guess, the variety of things is probably the biggest hallmark here.
Anyone else? Yes.
So I guess my understanding of sort of computer technology has been that, the measure of computer technology has always sort of been processing speed and memory. And recently, I guess I've kind of heard that has sort of starting to reach a plateau. It's getting harder to store more memory in the same space and process it as fast. It sounds like a lot of what you're saying, though, is a lot of our advances are coming from mining this data. So I guess, do you see sort of a point where it's going to be hard to work with this big data because we can't process or deal with it as much, that we're generating too much data too fast?
So what's interesting, there are these trends. Many of you have probably heard of Moore's Law, this idea that computers double in speed every 2 years. And this happened from like 1965 up until very recently, and that seems to have slowed down. And so that's kind of what he's referring to. Individual computers are not getting as faster at the rate they used to, but partially because of networks and things like that, larger and larger arrays of computers are being assembled. You guys have probably heard of data centers. What is a data center? A data center is where you've got thousands or tens of thousands of computers. Basically, the direction of technology improvement these days is more on larger numbers of computers connected together, okay, in big grids, big clusters, big networks. The reason why Google can do what it does is it has ways of wrangling hundreds of thousands of computers towards a common goal. And that's really where the extra power is coming from.
Which is to sell us stuff.
Which is to advertise stuff, I guess
Okay.
you can think of it.
Let's be clear. Largely, this is still about selling us stuff in the real world.
Yeah.
Right.
Okay. That segues into my question. Who's going to control this data? Who's going to own it? What proprietary rights will individual companies have? So you'll have this amazing mass of information that can control a lot of things and give insight into a lot of things that we all are doing. But if we as the public won't have access to it, how is that going to be safeguarded?
Well, part of it is a legal question. Different countries have different privacy laws, and the U.S. is certainly not at the forefront here. There's other countries in Europe that have, more restrictive privacy laws that might safeguard data better than here.
If I may interrupt for a second, there is in France, for example, there is something called the right to be forgotten.
We have to trust the French.
Well, I'm not endorsing it. I'm just saying that. So there are different standards.
The question of who owns the data, well, again, in our country, whenever you use a computer system, there's that long legalese thing that comes at the first web page you click on that says, click on here before we let you do anything. And you're giving them rights to use certain data, and, as
We've all read all of that before we pressed agree, right? Or everybody read every word. You're right.
So the question of how is it safeguarded, at least in this country right now, it is up to the individual company.
Anybody else? Any other questions?
But we're talking tonight, I feel the accent is on where we're going, maybe like it's a good thing. I'm just questioning, I don't know if it's a good thing. I think we're reaching overload.
As technology advances, is it good or bad? The answer, of course, is yes. Okay, there are good things about it, and there are bad things about it. Okay, and the hope has been, and I think a realistic hope is that the good is there's more good than there is bad. There's no question in my mind. Driverless cars are a wonderful thing. It will make our lives safer. It will enable us to do, I look forward to getting old enough that I can't drive anymore, and I'm going to be very, very happy when my car can drive me safely. And
All these blind, deaf 96-year-olds are still going to be behind the wheel. Maybe that'll be a good thing. It will help. Well, you know, a car is, for many people, aside from their home, the most expensive thing they own, and the average car sits idle 96% of the time, the private car. So the private car may be a thing of the past, and the only way the Long Island Expressway may be moving 20 or 30 years from now may be driverless cars.
You know, there's
there'll be
all
fewer
kinds of
them.
amazing
If you wonder
things
how that's going to be.
that can happen with driverless cars. Maybe you don't need parking in the city anymore because the car will drop you off and the car will drive to someplace where they can go.
Jersey.
Jersey.
Okay, well, any other questions? I want to thank Steve Skeena, who was just fascinating.
Thank you very much for having me here.
Thank you.
Okay, thanks a lot.
I want to thank the Stony Brook Yacht Club and the Alda Center, and that's wrapping up another Science on Tap. We'll be back pretty soon. Thanks very much.
Okay, thanks. Okay, I think that went okay.
Yeah, it was great. It was terrific.
Thank you very much.